All right. Hello, everyone. This is Yi, and welcome to the second video for this series where we're going to be talking about creating good figures. And in this case, the second video will be focusing on chart. So we're going to be primarily focusing on one line chart. We talked about grouping information, how we can do that. And we're also going to talk about how to create a chart in Excel using the embedded functions and elements. Excel is actually a very powerful tool, and most of the folks actually don't realize that there's just tons of hidden functions here in Excel. It's extremely powerful. When I was a master student, I actually used Excel to do the aggregation for probabilistic Sesame hazard analysis class, and we actually learned that. We learned so many functions that enables us to do a lot of very advanced computation in Excel. So that's actually pretty crazy. And so the nice thing about using Excel together with the PowerPoint is that it actually creates a pretty accessible software combo for most of us. Most of the universities or high school probably already have these free access to you as a student, and that's one of the nice things about it. And you also have equivalent free versions online that you can download and use. All right, but anyway, let's get started. So in this case, we're going to be looking at a design. So uh, of the chart. So we're looking at something like a 3-point bending test of a composite beam. So there are two designs we're comparing. One is different than the other one. And for each of the case, so we have case A and case B. Case A is here, that's the experiment. We have sample 1, sample 2, and sample 3. And again, for case B, the second design of this composite beam, I have sample 1, 2, and 3. So repeat the experiment 3 times. So the data would be looking like a force displacement curve that we could use to measure, to check the nonlinearity, to measure the stiffness, so on and so forth. So pretty standard testing for if you're working with metamaterial, mechanical metamaterial, or active structures, or soft robots. So these are pretty common graphs you would be doing. And then in addition to the experiment, I also have simulation. I have two simulations, one for case 1 and one for case B. All right, so let's see how we can create a chart. Go to Insert, select these two columns, and here's the chart. Scatter point count. Let's connect our point with the line, so that's gonna give us a pretty bare bone chart. Right, so we typically want to include multiple chart on top of each other. So let's draw that. We repeat that for all the 3 samples. And what we can do is we just click the chart, copy, Control C, and then Control V, paste it. And then again, Control C, paste it. Now we transfer all the data into one chart. Easy, right? This is ugly though, so we need to do a lot to make it usable in scientific publication. But bear with me, let's do the same thing for this case B. If I remember accurately, I think case B is a software design. So let's do the same thing. Create 3 chart. Click the chart, Control C, copy it. Click the chart, Control C, copy it. All right. And then I can copy this chart, paste it there. Here we are. So that's the 6 experimental lines of force displacement curves. So on top of that, I have 2 more of these here, this one and this one, right? We can do the same thing, copy paste. These are two simulation lines, and then copy paste, put them on top of this. The goal for today is to make this chart readable, make sure that the informations are grouped nicely, and turn this default graph into something that's usable in a actual journal publication. So if you stare at what we currently have, it's not usable at all. Yeah, it's not something I can put in my publication, right? So the first thing we need to do is the axis. We can select the axis, just double click, just click it once, right click. There's this format axis that will, let me move myself here. So we can bring out these right-hand side. It will help us to set up the features for the axis. So there's this axis option, and many journals actually require you to start everything from zero. So you need to do that. And for this case, it just looks like zero point 0.4 kilonewton is a good place to end the chart. And most of a journal will want you to have 3 to 5 ticks or this unit lines in a graph. So if I set my major unit to be 0.1, so we have 4 sections, that's usually pretty good. And we need to do the same thing with our horizontal axis. Again, start from 0. We need to do that. And it looks like we can truncate it at 6. Yep, that would be good. And then my major axis, let's do 2 millimeters so that I have about 3 sections on the right-hand side, and this will be good. So let's assume that we will put this graph to have a height and width to be 4, so that's occupying half of a page. So 4-inch, 4-inch, half a page. That's a very good number. So there's still a lot of things still missing here. And if we go to the chart design here, add chart element, we need the primary vertical title and also the primary horizontal title. So I can change the font of the figure to be Times New Roman. That's what we used previously, right? And then this would be displacement in millimeter. And here, this would be the y-axis will be force in Newton unit. Oh, excuse me, actually, kilonewton unit. That's correct. All right, so it looks better at this point. Everything is a little bit more organized. So depending on the journals, sometimes you're not allowed to show this grid line. So you can just select the grid line and delete it. And you typically will need to have a border line for these graph chart region. So you can click that, double click, and you can click a solid line, and that would create these outer border for that. You can also change the color to a darker color. And then here, let's click this axis again. In the axis options, there's these tick marks. So some journal will actually request you to to do not use that grid line, but only use the tick mark. So this is where you can turn on the tick mark to be for your major unit that you can select it to be in the inside. You will, I don't know, let's zoom in a little bit. This is the tick mark. So I don't know if you can see it. Hopefully you have enough resolution to see it. And again, tick mark. So that's something some journal will want you to put. Um, Some journals are more flexible in terms of how you display the major unit lines. So, and then if you want to bring back that grid lines, you can do the primary horizontal and then to the primary vertical. So I usually prefer to have a vertical, but some journals don't like it. They only allow you to use the tick mark. Uh, so you can change it in Excel, no problem. It's just a few clicks here and there, and this is fairly straightforward. All right. So the color of these lines is still very misleading at this point, right? We want a visual grouping of information. So for instance, these four lines at the top, they're for case A design. They're the stiffer design, right? And right now they're basically showing random color. The color does not reflect grouping of information at all, and this is not good. So what we can do here is we can change the color of all this line to be the same. Let's say we pick a dark grayish color for all of them. That's I think it's this one. Nope. Which one did I pick? I think it's this one. Right. Yep, that one. Okay. That's all picked the same color, right? So this will create some sort of grouping indicating that all of these four lines are for case A. And the second thing we want to do is to differentiate between experiment and simulation. So I can use width of the line and also type of the line to do that. So let's say I just set this to be 4 points, so be very bold. So the thick dotted line is for simulation. And the color shows that all these four lines, therefore, case A. Now, do I need to differentiate between sample one, sample two, and sample three? I don't, right? They're repeating the same experiment for 3 times. And I don't need to know which one is sample one. The reviewers don't need to know which one is sample one. And also the readers don't need to know which one is sample one, which is sample three. They don't need to differentiate between one, two, three in this case. So that's why the three experimental lines, it's actually better to keep them the same, using the same color so that we don't provide too much color that actually makes our brain add difficulty to our brain to understand what's going on in the graph. All right, so now that we have that figured out, we can do the same thing with the other case B. So in this case, you do see that the two lines, they're overlaid on top of each other. I'll show you one trick. In that situation, it's usually pretty hard to just directly click onto that line. So when you're selecting one line, you can press Control and up and down arrow that will move between different lines. So this is a pretty neat function in Excel that actually help you to get to the line you want to click, but maybe it's very hard to click onto it just because there's multiple line overlaying on top of each other. You can use Control up and down. That gives you a good way of moving around. And again, following the same principle, we set all the experimental lines to have the same light blue, thin line, solid line color. And then for the simulation, I change it to a very thick line with a dashed point. So now that this figure looks much better, we have information grouped in a very logical manner where the dotted lines represent the simulation, black color represents the case A design, this blue color represent the case B design, and then the thin lines are experiments. So it has good information grouping, and then the lines we don't, or we also don't differentiate lines that do not need to be differentiated from each other. All right, so this is a good place to start. And what we can do is we can copy paste this to the figure. So let's say I want a figure to occupy half a page. What do? I bring up the PowerPoint, right? And then I go to the design. I make the size of the figure to be 4" by 4", 4" in width. And then for this, if I want to bring in this big figure here, I actually need the height to be a little bit larger. So I think I need to go all the way to about 4.2" here. And let's just click Ensure Fit. That will not change the shape of the object. You can also click Maximize and then just go back to change the shape. That's also fine. Actually, it doesn't matter. So what I hope to do here is actually make this figure occupying approximately make this chart occupying approximately 2/3 the width of this figure. And the reason why I do that is because I still want to add in a legend for these figures. So if you go back to the Excel, I've actually deliberately did not include a legend here because the Excel will actually create a legend for each of these sample. So I have 3 sample. I just want one legend for all of them. In order to do that, I actually have to draw my own legend. So let's try to see how we can do that. So this is going to be part B. It's probably this large. And another thing you will notice is that when you copy paste the graph from Excel to PowerPoint, somehow Microsoft softwares has their own preference, so they're not going to copy paste everything following our instruction, which is a little bit frustrating, but yeah, we can change it. So I think if I change the points to be 1.5, it will match. Yeah, that's what I would do. So just change it a little bit. Make sure that the lines are like following what what we previously had. So okay, that's good. And then the font size again, I haven't changed it yet. So like we've discussed previously, we want it to be font size 8. All right, so I don't need that. Actually, let me keep that so that I can create the lines. So I need to create a menu legend. It's actually not hard. So for these, it's 4-point thickness, and then I think I can use this one, and then uh, the cap is round. All right, that matches much better. All right, okay, these two are line matches very well. So case A simulation, right? So we just copy paste what we have here. So this one is case A, it's from a simulation, right? And then I can copy paste this legend, put it downward, make sure I have a decent alignment. I just change the color of these to this bright blue and change this to case B, right? So I created this grouping of information through using a thicker line, and I provide the legends to show them. And then it's going to be for the experiment. Right? So case A experiment is just 1.5 point solid line, right? That's the 3 experimental line. And then again, because we don't need to differentiate sample 1 to 3, we directly use just provide these two legend. So if you ask Excel to directly give the legend for you, it will actually create a legend for every line individually. It doesn't allow you to do this sort of a grouping, which from my point of view is actually critically important. And it's actually also make the legends to match the way the lines are shown in the figure, right? The top two, these are simulation for and experiment for case A, they're darker, so let's put them on the top so that it um matches the more or less matches what you see in the chart. That creates another grouping effect that visually group the information that really helps the readers to get the information. All right, so this is it. This is I would say, a very good graph that would definitely help the readers to directly grasp what you're doing, right? So that's I said this is a composite beam, but then let's just assume that this is a reinforced concrete so that I can salvage this other illustration I created previously. So let's assume that for case A and case B are for different aspect ratio. I can insert this different, um, no, wait a minute. Sorry. Insert the different shapes um, to, I can draw additional lines to help show that these graphs are for different aspect ratio. So for instance, let's put a height of the beam here. So Times New Roman, bold and italic, and then font size is 8, right? So that will be good. And then we can move it here, put it here, group it and rotate it by 90 degree. So we need to mark down the length of this beam. I can put this load to be somewhere here. And I can change the color so that the load is visible, this arrow, right? So that would be good. Okay. All right. Now I can move this a little bit upward so that I can show the length at this location. Okay, perfect. Perfect. That's a perfect figure. Can make it a little bit longer. All right. So if I need additional explanation, I can say case A is larger aspect ratio. Excuse me. H over L. The height is taller, right? I can say the H over L is 0.2. And then the case B is H over L is just 0.15. So basically the case A is taller than case B, and because of that, it has a higher stiffness. And if I want to further make sure that there's no ambiguity in terms of what is changing that generate this different aspect ratio, I can just specify that this is a 1 meter long specimen, so 1000 millimeter, right? So now when you're just looking at the figure, you automatically knows what's going on in the experiment, right? So I have a beam I'm loading it to 200 kilonewton. That's the maximum load. It's 1 meter long, and one beam has like 20 centimeter, point two is, yeah, 20 centimeter height, and the other is like 15 centimeter high. And because of that, the taller beam actually produces higher stiffness, and the simulation matches that experiment fairly well. We repeated experiment 3 times for each of the design, right? It tells a story. The figure tells a story. That's what you want. And if you can create a figure like these, it really helps you to convey the information with the reviewer and also your reader. It's extremely important skill to have. And as you can see, we don't need a lot of fancy tools to achieve these. Excel, PowerPoints are more than ready to achieve this goal. So let me also show you how we can generate the PDF and also the PNG. So I show you how we can use the snipping tool last time. That's actually not the best tool. So at this step, you can definitely save this as a PDF file. So we've already talked about what's nice about the PDF file. As a final submission, the PDF is, it's a vector file, so you can zoom in like arbitrary, the text, the font is always clear, very sharp because it's vector graph, right? So you can zoom in like 100,000 times large, it's still gonna be very sharp. So once you have a PDF, so most of you probably already have access to Acrobat. That's probably the only Adobe software most university use because we do need to use that for documents very often. So in the PDF reader, you can save as, click Save As, and let's say we want to save to here. Um, we did select PNG, but for some reason, this software again is gonna shift back to the default as a PDF. But so anyway, go to the PNG and then make sure you click the setting. You do need to set up the resolution to be very, very high to get good results. So for your review manuscript, for a typical manuscript, I would say 6,000 pixel inch per inch is good enough. You typically would be targeting more than 300 pixel per inch. But let's say we just go one step even further, 1,200 pixel. Um, it's going to give you a reasonably sized PDF figure that you can use. It's not going to be very large, 180K. You can submit that into any sort of online paper submission portal with no trouble at all. And the nice thing about this is that it's super high resolution, so you can actually, you need to zoom in a lot to see this zigzagging shape. And this is how you get a high quality PNG or JPEG file out of the PDF you just rendered in the PowerPoint. And then again, this figure will look very nice on the 2-column journal, right? So the PNG, this is what we have here, right? It's the font size blends into these paper setting very well, and you probably have like what I've already showed you, right? You probably have 3, 4 paragraph talking about this experiment you're super exciting about. This sample is 1 meter long, different height. Each of the experiment you repeat it 3 times, and you have a simulation that matches fairly good. Um, and you have some text that helps you to just provide a little bit more detail about the figure, but the figure itself already conveys a lot of information and already shows the story to your reader. And that's actually one of the most important thing I do hope you can learn during this series of videos. All right, so that marks the end of these second video. So we've learned how to do chart using Excel, as you can see, it's a very powerful tool. It actually allows you to adjust all the elements you want to adjust in a figure. So with that, I would like to end this particular second video, and thank you very much for your attention. And I'm gonna wish you to have a great rest of your day, and I will see you next time.